Hello everyone, in this tutorial we will make our vehicle can do the multi-point turn, and we will make the line smoother and away from the obstacle. The vehicle can do the reverse alignment by move forward a little bit and can reverse. Also, the vehicle can change direction to forward if it have enough space. First, we need to do the line trace, forward, backward, left and right. Add function, line trace, obstacle forward. Add input. Input name is forward. Get actor location. Add. Get actor right vector. Multiply. Convert this to float. Get forward variable. Select float. If it true, set to 80, 95. Multiply this. Need to add brake vector, make vector, x to x, y to y, z, add with 50, need to z, get control rotation, brake rotator, create vector from your pitch, yaw to yaw, copy this forward. If it forward, the line length is 330, backward is minus 400. Multiply with this float and add with this location. Call line trace by channel. This is the start location and this is the add location. We select debug. Add a new variable is debug line trace. Get debug line trace. If it false, it's none. If it true, for 1 frame. And another line trace. Copy this. This is debug. Copy this location. We multiply this with float minus 1. Then connect this. This is the start location and add location. Return or Boolean like this. And connect to return. This is the line trace obstacle forward. And duplicate this function. Line trace obstacle right. For right, we don't need this. Forward, delete, convert to float, set to 220. And we rotate this 90 degree. 90. Change this forward to right. And this float is 120 and minus 120. We can copy this and delete this. Multiply with -1. Connect this. And this is start location, add location. Then add macros. The name is line trace obstacle. Input, execute, execution pin, execute. And output is then get spline actor. Check if it's valid. We can add to execute. The first is move and the second is stop. When it is not valid, we stop. Line trace obstacle forward. A variable is overlap front. Duplicate this. Overlap back. Overlap right. Overlap left. Then set this overlap front. Enable this forward. Then call overlap forward. We disable this. Set to overlap back. Call line trace obstacle right. Enable this right. Overlap right. And left. If We overlap front and overlap back. We stop the vehicle. Create the branch. Get vehicle movement component. Set handbrake to true. And call stop and wait. True. Need to stop. And if it falls, we move the vehicle. Go to event graph. And when we done process, the player process, call this line trace obstacle macro and connect move to this sequence. Compile and set this debug line trace to true. In this line trace obstacle forward, we can change this input to forward trace. Compile, get forward trace. Because it have the same name with other variables, so it confused with each other. Copy this forward trace. And another line trace obstacle. Input is right trace. So this one get right trace. Copy. And this. We need to change this get actor right vector to get actor forward vector. Copy and change this. File and save. Let's play. Now we have the correct line trace. Forward, backward, left and right. And after we trace, we set it to this variable overlap front, overlap back, overlap right, and overlap left. We close the line trace function. We need to do the speed trace in 4x4 grid to check that if we have enough space to turn the vehicle to the forward direction when the vehicle is moving backward. Add function. The function name is speed trace turn location. Add input. Pick left. For loop. First index is 0 and the last index is 3. And this index to float. Add with 1.5. and then call another for loop from 0 to 3. Get actor forward vector multiply with grid gap we multiply it with -1 and multiply with this float, this index. We convert this to float and connect. After that, we add this with get actor location add add get actor right vector multiply grid gap multiply with, convert this to integer, and this index we multiply get pick left select integer. If it's true, it is left, so we multiply it with -1, and if it false, it is right, set it to 1. Add with this get pick left, create a branch, add another variable is left location, vector array. Duplicate this, right location, get left, and add, and connect to this left. If it false, connect to this. These are the location for our speed trace. Add another function, call it speed trace pattern. This we forget E for sphere. First, we clear this variable left location, clear, right location, clear, call sequence, call speed trace pattern location, and the first one we choose left, and the second is right, so disable this. Then add another variable is can turn left, Boolean, single, duplicate, can turn right, add pin, this can turn left is true, get actor location, and get right vector, actor right vector, multiply with grid gap, to float, divide by 2, and we convert this to float. Add, we call pair trace by channel, and this is start location and add location. We get this grid gap location as the radius. Because we want to make sure that the right location, they don't have the obstacle. Create a branch. Call can turn left and set it to false. Get left location from the array for each loop. Copy the spear trace and the start and add. Use this grid gap location, radius, create a branch. If any one of these locations overlap, we set this can turn left to false. We can use for each loop with break because only one overlap, we will stop this loop. Need to display when it's true. Similar to this, just opposite direction. We can copy this. And this one call can turn right. Set it to true. If it overlap, we set it to false. We multiply this grid gap by -1 because we want to check the left direction also. And this left location, change it to right location. After all of this, we return, call return, and move it down here. Add macro. Name this macro to can perform K-turn. Input, execution, execute, and output. Then call the spear trace K-turn. Get can turn left and get can turn right, and boolean. Create a branch. Get turn left or boolean. Can turn right. Create a branch. If this false, we delay. When it true, for 0.2 seconds, add another variable is do K-turn. This K-turn is 3-point turn. It's the same. And create a branch. Add another function. This function name is find next spline location. Input next index. Integer. Get spline actor. Get spline. Get location at spline point. Coordinate space is world. From this spline, we find input key closest to world. Get actor location. Call seal. Connect to this point index. And then we return. We return this value. And this seal we add with this next index. Set this to pure function. Go back to can perform K-turn. This find next spline location. Set the default value to 2. Call find next spline location. And add vector is turn target. Set it to vector. If it falls, we set this to turn target. And when it's true, we set this turn target. Add another variable. Name is forward turn. Change to boolean. Set it to false. We do the dot product between the right vector to the turn target vector to know that if we should turn left or turn right. Get actor right vector on dot product. Get actor location. get unit direction with turn target and connect to dot product greater than 0. Create a branch. And turn left if it's true. We add another variable is debug pattern and get this debug pattern, create a branch. That is when it's true. Get left location for each loop. We draw debug sphere. With this left location that we do the speed trace. Radius is 25 and change this to red. Duration is 2 and thickness is 1. If this false, we check if can turn right is true. And this debug. Get right location. Call for each loop. And draw debug sphere. And output. If it false, this debug false, we also connect to this output. And when this complete, in macros, when we don't connect to output, example, when this false, it will not execute outside these macros. We already have this can perform return function. Now we add another macro. Name is can perform turn maneuver. Because we will have different kind of turn for this vehicle. Input execute get forward boolean not forward not boolean avoiding obstacle and if it's true. Can perform pattern and we get do pattern. If this false, we set this do pattern to true. We only check this speed trace when the vehicle move backward and it is avoiding obstacle. We can close all of this function. In the event graph, from this sequence, we can call this can perform turn maneuver. And after this move, do K-turn. If it's true, we need to do performing K-turn function. Need to add another function. Is perform K-turn. Go to event graph and set this perform K-turn. Call print string. Set this duration to 0. And this one is K-turn. And search for debug. K-turn. Compile. Set to true. Hit save and play test. Now the vehicle moving backward, and then it's detect that this location have the available space to do the K-turn. We can delete this print string, add another function, turn vehicle with target location, and click on this function, add input. This input is forward. Forward is Boolean, and this one is target. Change this to vector. Create branch. If it's true, we get vehicle movement component, get forward speed mph, and it's less than target speed. Absolute. Create a branch. Copy this. And when it falls, we multiply this target speed with -1 greater than this. Create a branch. Vehicle movement component. Set throttle input to 1. When it's true, and set this throttle input to -1 when this falls. We call set brake input. Set it to 0. And set the steering. Set steering input. The steering, we get actor, fly vector, and we dot product with actor location. Unit direction with the target. The target. And connect to dot product. Check if greater than 0. Select float. 1 and -1. And this is the steering. And another one is the brake. Is to move backward. Get vehicle movement component. Set brake input to 1. And set brake input to -1. Then we call set throttle to 0. We set this to 0 because when we call this set throttle, if we change to this, it will have the default value for this throttle. So we need to set it to 0. And next is the steering input. Copy all of this. The same for everything, but this float is opposite, -1 and 1. Delete this. And let's compile. Add another function. This function name is has completed direction change. Get actor forward vector. And then call dot product. Get line actor. Get spline. Get direction at spline point. And word coordinate from this spline. Find input key closest to world location. Get actor location. Call truncate next to this point index. And do the dot product. Call equals degree. In range float from 0 to 5. And another condition is actor forward vector with dot product with actor location unit direction to turn target. And connect to this dot product. Call equals degree. The same in range. So if the vehicle direction is the same direction as this spline direction and as this turn target, we will complete the K-turn. Another condition is we check the location. Get actor location. Get the distance. Get spline actor and spline. Find location closest to world location. And this is the world. to this distance. Check if it's greater than grid gap. To plot, multiply with 2. Create or boolean or call return. Next to this return and connect this to this. Change this to pure function. Let's save all of this. To perform k-turn, we get min speed, set to target speed. All has complete direction change. When it falls, we create a sequence and get overlap front. Create a branch. If it's true, we still not complete the direction change. And then get overlap front. Create a branch. If it's true, forward, step forward, turn to false. Get overlap back. If it's true, forward turn is true. And then find next spline location. Call set turn target. At this pin, we get vehicle movement component that handbrake to fall. Call turn vehicle with target location. And we get this forward turn. Get forward turn next to this. And the target is turn target. Get debug k-turn. Create a branch. If it's true, we draw debug spear. Get turn target. Draw debug spear. The radius is 30 and change this color to green. Duration 0 and thickness is 2. When we complete this k-turn, if this fall, we get vehicle movement component called set handbrake to true. Hit this. Set brake input to 0. Set throttle input to 0. And set steering input to 0. After that, we need to change the spline point data. Get spline actor. Get spline. Spline point data array. Call for each loop. From this array, we call that array element and use this array index as the index. Make item and fit size to fit, and we set this to move forward. After we complete, we call forward, set it to true, and do k-turn, set this to false because we complete this k-turn. When we check this can perform turn maneuver and this do k-turn is true, we perform the k-turn. Let's play. See if this works. Now our vehicle can change the direction to forward when it's have enough space. Let's see another side. And now the vehicle can change to correct direction. Next, we want the vehicle to perform K-turn in the tight space. Add another macro. Can perform high K-turn. Input. Execute. And output. Call speed trace by channel. Get actor location. Get actor drive vector. Multiply. Get grid gap. Convert it to float first. Multiply with 1.2. And then we change this to float. Multiply and add with this actor location. This is the start. Sorry, this is the start and this is the add. For this grid gap, we connect to radius. We can draw the debug for one frame. We can draw the debug for a duration. Copy this. Multiply this with -1. The right vector change to the left vector. And call n boolean. If both of it is true, get actor forward vector dot product, get actor location unit direction, find next line location, and next index is 2. Dot product greater than 0. Create a branch. If this is true, we set to this and we connect to this output. If it false, we don't do the IK turn. Get overlap right, get overlap left, or boolean. Create a branch. When it fall, connect to this and connect fall to this output. To check this, we need to go to event graph and can perform turn maneuver, create a sequence. Overlap front, avoiding obstacle, and create a branch. Call can perform IK turn. Find next Spline location and set to turn target. This do K turn. When it falls, we set to do K turn is true. Now let's move this here. If the forward line trace is overlap with this obstacle and then we have the left or the right location, we can do this K turn. Let's play. And you can see the vehicle do the K turn. This is multi-point turn inside this because we have enough space to do it. We can disable the debug. Change this to none and none. And move it here. And do this again. Play. Next, we need the vehicle to able to do the reverse alignment. Example, when the vehicle don't have the correct angle and This time the vehicle need to reverse, but the angle is not correct. So the vehicle need to move forward a little bit and turn like this and move backward. The tool we call AI can perform turn maneuver. We check this when the vehicle is reversing and is avoiding obstacle. We add a sequence. Get overlap back and do K-turn. The vehicle didn't do K-turn. Not Boolean. We add a branch. If this condition is true, we set this turn target and add another variable is do reverse alignment. Set this to true. Go to event graph. Move this a little bit backward. Or do reverse alignment. Create a branch. Add another function. Perform reverse alignment. And call this function. This function is similar to this perform K-turn but in reverse. So we can copy from this perform K-turn, copy all of this, paste it here. For this turn vehicle with target location, we add another variable is opposite turn. Set this to Boolean. And then we multiply this vector with negative when it's turn, opposite turn. Get opposite turn like float. -1 and 1. This is the float next to this float. The same with the other one. When we reverse, multiply with float. Compile. This has complete direction change. Add input. Opposite turn. And we get this opposite turn. Select float. -1 and 1. Then we multiply with float to this. And we go to perform reverse alignment. We set this opposite turn to true and this one to true. This overlap front, we change this to overlap back. When it's complete, we don't set this spline point data. Just delete this and set forward variable to false and change this do turn. Set do reverse alignment to false. We can change this debug color to red when we do the reverse. Close all of this. Go to this spear trace grid and change this grid gap. Divide it by 2 to make this grid gap is smaller so it can detect the path to get out the obstacle in the tight space. Path and save. Let's play this. Now our vehicle move forward a little bit and then move backward. We don't need the debug this debug grid. Next, we need to improve the spline. When we spawn this new spline, we need to adjust the spline location away from the obstacle. Add another function. Adjust path away from obstacle. Input vector array and original path. This one is integer. Spear radius. Change to float. Single. Call for each loop. And we set original position. Add another variable. Local one is original position. Set to vector. Set this. Add local variable is sum normal. Set it to 0. Call multi-spear trace by channel. Start location is this array element location and add location. Get spear radius to this radius and then we create the branch. When it's full, we add another variable is local adjusted path array. Add with original position. When it's full, And if it overlap, we get all the overlap component. Break this hit. And we need to add to the normal vector the sum of the normal vector. So this impact location get distance, original position, get spear radius, subtract with this distance, and create absolute, multiply with this normal vector, convert to float, multiply, get sum normal, add it, and set to sum normal. And for this loop body, if all of this hit object is complete, we get local adjust path and add it to the array. Get length of this hit, get sum normal, divide with this length, get original position, add this, and connect to this add. If you want to draw debug arrow, this original position and this one, the line add, we can change this to purple color. Arrow size is 1, duration is 5, and thickness is 3. When all of this complete, we return local adjusted path. This is the adjusted path that we will use. Change this name to adjusted path. You can see if we don't overlap, we just use the original position of the spline position. And if we overlap, we add the normal multiplied by the distance, and then we adjust this location with that normal. Go to event graph, and we can call this adjust path. This path location, this radius is grid gap. To float, multiply with 1.6. Next to spear radius, and set to path location. And this spawn new spline will take this path location to create the spline. Let's play. You can see this is the original location, and the new location is away from the obstacle. We can rotate this vehicle 0 degree and then go to vehicle AI. From our plugin, we have a few functions that we will use. Merge close point. Sometimes when we adjust the path, this point will stay in near each other. So we can merge those points together. And this grid gap multiply with 0.7. And this is the distance threshold. We can collapse this as a function. The function name is refine path with obstacle avoidance. Return is adjusted path. Compile. After we merge, we can do the relax. Call relax path to make the path look smoother because we can see the zigzag of the spline. Iteration is 5 and relaxation set to 0.25. Before we relax, we add middle point for the point that is far away from each other. Add midpoint if far apart. The max threshold can copy this grid gap is 0.5. And after we add midpoint, we do another adjust pathway from obstacle again. Disconnect this. After that, we relax that line and do another adjust path away from obstacle. After we relax, the point will stay near the obstacle a little bit. So we do this again. And then we do the final relax path. Iteration is 2. We just do the relaxation a little bit. And this one is 0.2. And this is the adjusted path. Compile. And let's play test. Here we can see the smooth path along this. And we don't need the debug. Let's go to adjust pathway and disconnect this draw debug arrow. Save all. We have a problem because when the vehicle is near this wall, the vehicle still try to turn. So we want the vehicle don't turn when the right or the left line trace overlap with the obstacle. This only happens when the vehicle moves backward. It causes the swaying turn radius. Go to event graph. And this steering input get overlap left or overlap right. And get forward. Not boolean. Need to end. Select float. If this true, we set this turn input to 0. So the vehicle will stop turning. Let's play this, see if it's work. Now the vehicle stop turning when the right line trace overlap with the obstacle. We already complete, but we can change this group of the variable to make this look cleaner. This default speed change to speed control. Target speed is speed control. Your data is category is steering. Create a new category. Offset tangent is steering. Forward steering. Highest input key steering. Freeze actor location steering. This debug line trace to debug control. Debug K-turn to debug control. And this left location, add a new category is K-turn. Right location, K-turn. Can turn left, K-turn. Can turn right, K-turn. Do K-turn, K-turn. Turn target, K-turn. Forward turn, K-turn. This do reverse alignment, K-turn. And now it's look better. And close all of this. And this debug map array, you can delete it. If you need to debug, you don't need to delete it. If you don't use it anymore, you can delete it. And you can adjust the min speed if you feel the vehicle moving too slow. Change this to 7 or change it to 6 first. Compile. We can comment this, select C to comment. This one is steering and throttle. I set up the new obstacle for the vehicle. And now we can play in full screen. Press F11, LP to play. We can remove this debug. Steering, set it to false, and debug line trace to false. This is the end of our tutorial. Thank you very much for watching. If you like this tutorial, please hit like and please subscribe to my YouTube channel. Thank you very much for my patrons member who are supporting me. Your support really means a lot to me. See you in the next tutorial.